loose ends with this topic of how we can use calculus to kind of answer these types of word problems. So again, this isn't OneNote if you're looking for it. It is, I'm skipping the water tank one, like it's doable, it's just like not that exciting. But this one does have a lot of calculator stuff that I do want to kind of show you. So let's just go ahead and get started. Yesterday when we were doing these problems, we just kind of looked at setting up the problem, like we didn't really have any numbers, so there wasn't anything to really like calculate or anything like that. Today, I just want to make sure we knew how to calculate it. I also chose this one just because it does have a candidates test on it. So I get there, but it's question D. I know those of you who had me last semester, hopefully you're pretty confident with the candidates test. I know some of you are new to me, so I didn't want to use that time to kind of review a candidates test. But also really for everyone, a candidates test is really going to be pretty different for these problems. But this one is a calculator one, so I will also just show you some like tips and tricks of things that you can do in your calculator to kind of save you just like a few seconds of just typing stuff in. But yeah, let's go ahead and start answering this one. So looking at the question, we have this haunted house. And these questions will always have like a similar format. Like however it's formed, there's always going to be something that are consistent. We're always going to have some function representing the rate of something like entering or like some input rate. So like in this case, we have a haunted house. People are entering by this function EFT. It is a rate measured in people per hour. Also important things that we see is that EFT function is only good when you're looking at from 6 to 12. So that is basically the input function. This is going to be the rate that people are entering the haunted house. Then we also have an initial condition. At t is equal to 6, no one is inside, so t equal to 6 would be equal to 0. And then you will always have kind of like an output kind of rate for these problems. And for this one, we can see the output is no one is leaving until 7, and people leave at a constant rate of 110 people per hour. So that 110 in itself really is just going to be another function. So we have EFT, the rate of people arriving, the 110, the rate of people leaving. So there's always going to be two parts to this question. We always want to make sure we kind of show the setup, and then the second part will be actually like finding the integral or like finding the value. So looking at question A, it says how many people enter the haunted house from t is equal to 6 to t is equal to 7. So when I approach this problem, I kind of think to myself, like, what do I need to do to set it up? If I'm looking for how many people, I'm looking for the amount of people that are entering the haunted house. Well, that EFT function is measured in people per hour. In calculus, how am I going to convert people per hour into people? We take the integral. So I know I'm going to have to integrate. Which function am I going to do that with? EFT. Don't forget the dt at the end. And then we want to know how many people enter starting at 6 and then ending at 7. We know there's two types of questions that kind of involve the integral. Some of them use the initial condition, some of them don't. Would this be one that uses the initial condition?
Yes and no, because there's no one.
So the initial condition is 0, but if it was a different number, well, we need to make sure we include it. And would we know, and how do we know there's no initial condition? We are just concerned about what's happening starting at 6 and ending at 7. So from 6 to 7, how many people entered? That would be the number of people who have entered. So that's where we stopped at yesterday. Today we're just going to evaluate it. So again, I'm looking at my calculator just to remind us how to use it. Again, my instructions are for the TI 8384. If you have another one, bad answer as a teacher, but you are going to have to like figure out how to use it yourself because I'm just not familiar with all the other graphing calculators. Math 9 is how we pull up the integral operation. Starting from 6, ending at 7, we want to know how many people entered, so I'm going to integrate the rate. Remember, integrating a rate is going to give you an amount. So I have 144 minus x squared, closing the parentheses, and then second e sine of x. And for a problem like this, they're going to give you a pretty crazy integral just so you do have to rely on the calculator to do it. dx and then hit enter. And so I see that we get 128.4. So like 0.4 of a person have made it inside the door, but it does tell us to round it to the nearest whole number. So how many people have entered? We have 128 people. Didn't ask for units, but I do like including units on my question. So that was that first one. Any questions on that, either the setup or how I got to the answer? All right, so let's go ahead and look at B. Looking at B, let me zoom out a little bit. At 9 p.m., is the number of people inside the haunted house increasing or decreasing? I chose this problem because of all the questions I ask in this kind of topic. This is the question that I see students mess up on the most often. And I know why they mess up is that people see like this number of people and they're like, oh, that's the number of people, I need to find an amount. But this question isn't technically asking you to find an amount. What it's asking you to find is asking you to determine whether the number of people is increasing or decreasing. So we don't want to find an amount. For example, there could be like a ton of people inside the haunted house, but they could be leaving really, really fast, so that number would be decreasing. So since we are looking at whether it's increasing or decreasing, if any problem is asking you to do that, you always want to compare the rates. What rates are you going to compare? You want to compare the rate in with the rate going out. So we do have two rates. One of them is a constant, so that's nice. We know that there's 110 people per hour leaving. We want to be able to compare that to the number of people who are entering per hour. Well, how can I find the number of people entering per hour? EFT, right? So that is the function that is representing a rate. So we just want to find E of 9. How do we find E of 9? Well, we have a calculator, so we just got to type it in and find what that rate is. Again, obnoxious to type in again, but I have 144 minus 9 squared times second E to the sine of 9. And I see that would be the rate. So at 9 p.m., we have 95. Didn't tell me around it, so I'm going to use 3 decimals, 0.130, and that's people per hour. And I do want to make sure I kind of compare those clearly. Well, which one's happening faster? 110 is the bigger one. So then I can kind of draw my conclusion from there. So I found P is 9. That gave me 95.13 people per hour entering. I know from the problem there's 110 people leaving per hour. So would the number of people be increasing or decreasing? Decreasing. People are leaving a lot faster than they're entering. So because of that, so the number of people is decreasing. So I have my reason, I showed the math, my calculator did it for me, and then I had kind of my justification after it. Questions on that problem? And again, the big mistake I see on that one, whenever you see a question asking you for something increasing or decreasing, you want to make sure you're always comparing the rates, not the amount. Yeah, Marty?
How come it wouldn't be like 110 times 9?
Good question. So that is like, it's a constant rate. So it's not 110t. Like that is the equation. So it's kind of like saying like they could have named it like maybe like L of t is equal to 110, but like 110 is the function. That is the rate always, no matter what. So we're going to compare the rate to the 110. So moving into C, we are going to kind of compare to A. So I'm actually going to zoom out. There we go, so we can kind of see them on the same page. So looking at A, it asked us how many people entered the haunted house from 6 to 7. So we just had that single integral from 6 to 7. Looking at C, it asks it a little bit differently. It asks you how many people are inside the haunted house at 10 p.m. So we just have one time to talk about. So the way that we're kind of interpreting that one is up until 10 p.m., overall total, how many people are in the haunted house. That's going to include the number you started with, all the people who have entered till 10, and then subtracting all the people who have left up until 10. So this one, again, we're going to set it up and then use our calculator to kind of evaluate it. This problem, would we technically need to use the initial condition?
Yes.
Yes, it is 0, so if you left it off, you'll get lucky and you're still going to get the right answer. I'm going to write down just to remind yourselves it does exist. So there's 0 people in the haunted house. At what time did we have 0 people? 6. And then what's going to be the top number? 10. And that's going to be the EFT function. DT, don't forget that. And then minus, what is the rate that people are leaving? People are leaving at 110 people per hour. That still is going to 10. But for this one, what is that bottom number on that interval sign going to be?
7.
7. So you do want to make sure you kind of read the question well. And I'll scroll back up so we can all see it. People did start entering the haunted house at 6, but it takes them about an hour to go through it. So no one left the haunted house until 7. So when I integrate that second one, we do want to make sure that it is starting at 7 and not 6. Since those intervals are not the same, we can't combine this into a single interval. We are going to leave it as one from 6 to 10, and then the other one from 7 to 10. So again, I am just going to go ahead and type this in my calculator. I am going to be lazy and just kind of scroll up first and select that first integral I used. And I didn't need to worry about the 0, but I'm going to change that 7 to a 10. Oops. So that would be the amount of people who have entered total, but then people start leaving at 7. So minus math 9. So from 7 to 10. What's the function people are leaving by? They're leaving at a rate of 110. And then that would be dx. And then enter. And we see that there's a total of 225.529. Does ask us to round to the whole number since we are talking about people. So that would be 226 people. Questions on that? Yes, Taylor?
My calculator's not working and I don't know why. That was still from the first one, but I don't know why.
You put a negative instead of a minus.
Oh, okay.
Any other questions on those 3? All right, so let's go ahead and look at D. If you're dozing off, go ahead and wake yourself up for D. This one is gonna be a ride. It's a long question, even though it doesn't look that long. There's actually a lot of things we have to consider for this question. So I do want to kind of just like talk about why there's a lot to consider and then go through all the steps and then also show you some shortcuts in the calculator. So if you don't listen to anything today, listen to this part D. And so it says at what value within the interval from 7 to 12 is the number of people inside the haunted house at a maximum. So we're looking to try to find the most number of people. In this class, whenever you're asked to find the most, the maximum, the least, the minimum, the absolute maximum, the absolute minimum, any of those kind of like extremes, what is it that you're going to have to create? You're going to have to create a candidates test. So like, let's review candidates tests, especially for those of you who are new to me and everyone who probably just needs to review it anyway. When we do a candidates test, it is just a fancy t-chart where we have like the x and the original function. And there's 2 types of x values that you need to find to put on that candidates test. What's one set of x values you always have to include?
Endpoints.
The endpoints. So you always want to make sure you include the endpoints. And then what is the other set you always want to make sure you include? The critical points, yes. So where the derivative is equal to 0 or undefined. So that's a normal candidates test. But this is not such a normal Canvas test. We're talking about like people entering and exiting a haunted house. So let's just kind of convert this in terms of like this problem. We're still going to have a candidates test, but we're trying to find the maximum number of people. Instead of x's, we're trying to find when that happens. That's going to be your t. There's not really an original function. We're going to think like, what are you trying to find the maximum of? You're trying to find the maximum number of people. Then you want to go ahead and fill in that candidates test. Again, kind of the same idea. What two sets of numbers are always going to go in your candidates test? You have the easy ones to find, the endpoints. Here's the interval we're considering. We want to find the maximum number of people between 7 and 12. So I know we're starting at 7 and ending at 12. The other thing we want to find is the critical point. This is where oftentimes students forget or they just don't remember how to find them. So let's talk about how we would find those critical points for a problem like this. In calculus, we know the critical points occur when the derivative is equal to 0 or undefined. For these types of problems, instead of saying the derivative, what might we say instead? The rate. So we know the derivative is basically representing a rate. So we're basically looking for when the rate is equal to 0. And that's where your critical points are going to be. Well, what does it mean for the rate to be equal to 0? We do have two rates happening. We have the rate that people are entering minus the rate that people are leaving. That would be the overall rate. So you have like the input minus the output. And we do want to find when that is equal to 0. Me personally, I don't like solving that equation. There's just some things that can sometimes make it complicated. The one that I think is also just easier to memorize is if you move that 110 over, it becomes E of t is equal to 110. So if you just want to summarize, like Mr. Brown, just give me something to memorize. For these problems to find a critical point, you want to find when the rate in is equal to the rate out. You might be able to reason your way of why that would be considered a critical point. It's kind of like the equilibrium, like before that equilibrium, it might be flowing in faster. After that equilibrium, it might be flowing out faster. So it's kind of like that balancing point of where something important could possibly happen. Now, how are we going to solve this equation? Like scrolling back up, I'll come back down to a second. E of t, that is not a cute function by any means. In fact, that is not a function that we can solve by hand. But we have our calculator, and our calculator can solve it for us. So disclaimer about solving in our calculator. Those of you who either took AP Physics or are currently in AP Physics, I know you've used that solver a lot. We can't use that in calculus. That solver works nice for chemistry because you're solving, honestly, you're solving simple equations. You're solving polynomials, you're solving like rational equations, and you're solving radical equations. Like they are simple in terms of like the math that requires to solve it. How we're going to have to solve equations in calculus is because we typically have equations that have like possibly multiple answers. They might be really, really big values as well. We're going to solve them by graphing them. And that's when I like thinking of it where we're basically trying to find where the rate in is equal to the rate out. I'm basically trying to find where those graphs are going to intersect each other. So let's graph them. Not using the solver, it won't work. Try it, it won't work. We're going to go to y equals and just type in those equations into your graph. So I'm going to type in E of t into y1, and this is kind of already there for me because I did this twice already today. But y1, you're going to type in E of t. Make sure you type it in correctly, because if you don't type it in correctly, you're not going to find the right intersection point. And I'm going to type in the other rate into y2. Again, for this question, that y2 is 110, but it could have the problem could have given us like a different, like an actual equation for the rate out. Like you basically want to just type in the rates into y1 and y2. And then you do want to graph it. So I'll give you a second to type it in. Definitely follow along with me. Definitely, hopefully you've already double checked that your calculator is in radian at this point. So when you go to graph this, the easiest way to graph something in a calculator is hit zoom 6. But clearly when we type on that, we don't see a graph and then you're like, why don't I see anything? And then you look and you're like, oh, we're dealing with some pretty big numbers. So like, we just don't see what we're trying to find. So we're gonna hit window instead. And I like changing my window to just fit exactly what I need to see. So I only care about the interval from 7 to 12. So I'm just gonna go ahead and change my X minimum to 7 and my X maximum to 12. Like I don't care what's happening before or after that. So I'm just gonna go ahead and change that as my starting and ending point. And then for my Y min and Y max, in part B, like we know that E of 9 was 95, like the other rate is 110, so I need to go to at least 110. So I'm going to type in just something big. I can always change it later. I don't know, 200 feels like a good number to try. And then instead of hitting zoom 6, I'll just hit graph. And we'll graph it. I look at that, like I can see the intersection point, so I could answer the question like that. If you want to see the whole question, then maybe you'll hit window again and type in a bigger number for your Y max. Didn't have to, you mainly just want to make sure you can see the intersection point. And so when you're looking at this, and then I'll kind of pause for a second and let you catch up. The biggest mistake I see is people look at this graph. This blue one is representing your EFT. The red one is representing the 110. That's the rate people are leaving. And people see this high point and they're like, hey, that's where the most people are in the haunted house. That's definitely not when the most people are going to be in the haunted house, because you want to think, even though that blue function is decreasing, it's still higher than the red function. So people are still entering the haunted house faster than they're leaving. That equilibrium point is probably where the maximum number of people are. We just have to kind of justify that using our candidates test. Questions on anything I've done so far? Yes, Mitch?
So I got, is the blue line supposed to be the sign function?
I mean, it depends on how your calculator. So mine was blue because that was what was beside the Y one.
Okay,
So yours might be.
I got 2 straight lines.
So you probably typed in the function wrong. So I just double check how you typed in EFT. So we want to find, or you had a question, sorry.
Yeah, press zoom 0, it'll zoom 0 for you.
Yes, I don't use zoom 0 to do zoom fit only because we're only focusing on from 6 to 12. So like if you do zoom fit, you might see other intersection points that you don't need to deal with. So as long as you know that you don't need to find them, that's fine. But especially for a trig one, you might see like 5 or 6 intersection points. When if you fit the window to the interval we're looking at, then you might only have to find like 2 of them or 1 of them. So just be careful with using that kind of operation. So how do we find the intersection points? The calculator can do all the work for us. You're going to hit second trace, which is second calc, and it's going to be option 5, the intersection point. And you can just hit the number 5 and it will select it automatically. And then it was going to ask you a series of questions. It's like, hey, is this your first curve? And you're looking at where it's blinking. You're like, yep, that's one of my curves. Enter. And then it goes, hey, is that your second curve? Yep, that's my second equation. Hit enter. And then it does want you to guess. And the guess is important. So we only have 1 intersection point, so the calculator is not going to get confused. Whatever the cursor is closest to, that's the intersection point it's going to find. Also, some advice. Sometimes if your cursor is far away from that intersection point, like your calculator is just going to like be thinking and thinking and thinking and thinking, and you can speed things up by just moving your cursor closer to that intersection point. So then I hit enter, and it will find that intersection point for me. I know if you're in class right now, you probably can't see that number because it's really small, but it is 8.875. And so that is the critical point for this situation. So again, let's make sure we're all kind of on the same page where we're at. The most number of people are going to be in this haunted house at either the 7, the 12, or that 8.875. Don't want to overwhelm you with a bunch of clicks, but I love a good shortcut if I can. Typing in that decimal in the integral over and over gets old really fast. So you can just tell your calculator, again, it's just a small computer, to just, hey, memorize that decimal. How can you tell your calculator to memorize that decimal? Immediately after you found that intersection point, just go ahead and do like second quit, go back to your home screen, and you're going to click X, because right now your calculator thinks that X is the intersection point. Then I'm gonna hit store, which is above the on button. And I'm just gonna pick a different letter of the alphabet. I'm gonna choose A, because it's the first one. So I'm gonna hit alpha A. And now, instead of having to type in that 8.875, blah, 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 I can just do alpha A, because now my calculator has saved that intersection point as A. So it would just save me some time in evaluating it. So let's think about why I would have wanted to save it. So let's go back to my candidates test. We're trying to find the number of people. So ask yourself, well, how many people are there at 7? How many people do we have at 7? That would be the integral. People started arriving at 6. They left at 7. I should be better with that. Started with 0 people. People started arriving at 6. We're freezing time at 7. Since we're freezing time at 7, no one has left yet. You would either reevaluate that in your calculator or be smart. You actually found that answer in part A. That was 128 people. Thanks. And then you want to do that for each of the rows. So like for the second row,
A surface pen in here?
you can see.
Is that the next one?
No, there's one there.
So then for the second row, again, think about what's happening. You had 0 people in the haunted house. People started entering at 6. We're freezing time at this 8.875. And we're integrating this EFT DT. We're beyond 7, so people are also leaving. How many people have left? People start leaving at 7. They stop leaving at the 8.875, and the rate was the 110 DT. I'll come back and evaluate that in a second. And then 12 started with 12 people. People started arriving at 6. It closes at 12. How many people left? Starting at 7, ending at 12. The 110 DT. And I am going to use my calculator to evaluate those. Again, I am going to show you some other shortcuts you can use. And the second row, so we have 0 plus math 9, starting at 6, ending at, so you're either going to type in that whole decimal, 8.875, blah, 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 or if you saved it as A, I'm going to hit alpha A. Another shortcut, don't want to overwhelm you. You either type in EFT, or your calculator now knows what EFT is. Where did we type in EFT at? Y1. So if we can select Y1, we don't have to type it in again. Well, how can we select Y1? You're going to hit vars. It stands for variables. It's next to the clear button. And then Y variables, so scroll over. It was a function we typed in. What function did we type in? Y1. Again, some people don't trust that. They're like, I just can't see what that is. So they just want to type it in. And if you want to type it all in again, then be my guest. I'm going to be short and kind of do it that way. And then dx, and then minus math 9. This integral is going from 7 to alpha A, or again, type in that decimal. Could go select the 110, but it's easy enough to type in. And then I have dx. So how many people are in the haunted house at that time? 283. Marcus, you had your hand up.
Yeah, there's something to store like the equation and have it fit into the.
So the only way to store the equation, like you can always just type it into Y1, and then you can always go back and select it with, even if you haven't graphed it.
Okay.
So like at the beginning, if you wanted to, you could have typed it into Y1 and then just always selected it doing that step. Yes, sir, Monty.
When we're doing the candidate test, like we're writing the integral, if you don't write it to 3 decimal places in your work, will you get like?
You should just get used to writing it to 3 decimals in your work, is the short answer to that question. Was there another hand up? Sarah.
I'm sorry, how did you get your Y1 back into the?
Yeah, I'll do it again. So I could for that third row, just arrow up and select it. Actually, that's what I'm going to, no, I'll type it in. Again, to get to that Y1, you're going to hit just gonna type this in real fast. This one's going from 6 to 12. Again, to get to the Y1, you're gonna hit the vars button. It's next to clear. And then you're gonna scroll over because it's a Y variable, and you are selecting a function. And then which function did you save it as? I hit enter twice too fast. Oh, I didn't. But then it'll be selecting the Y1.
Thank you.
And finishing it out, math 9, 7, 212 of the 110. And you're like, Mr. Brown, this is a lot of work. And I'm like, well, so is getting college credit for a class. So that's what we're going to do. And we see that at 12, we have 25 people in the haunted house. So how would I answer the question? We're looking for the maximum number of people in the haunted house. Well, what was the maximum number of people in the haunted house? 283. So maximum number of people is 283. Didn't ask you when that occurred, but that occurred at t is equal to 8.875. So pretty close to 9 p.m. So that's the candidates test for this problem. I did choose one that was like the absolute longest candidates test that you could have. They definitely are not all that long to do. Like for example, if you just had a graph in front of you to find the integral, you just divide it up into like some rectangles and triangles. The ones that do have a candidates test in the homework, in case you wanted to make a note of it, and then I will kind of open it up for questions. In homework 2, part B1D, that one you have to create a candidates test, and that one is just like the one we just did, but there are 2 points of intersection you have to find. The other candidates test is in B3, and it is part C. When is the ride the longest? But that one will be a little bit easier to do because you can use the graph to find the definite interval. So with that being said, like that's what I wanted to do today. I know that took a lot of time, but it was important to get done. Any questions on that last part that you wanted to get answered? Yes, sir.
Well, I just keep on getting a different answer for my x.
Okay, I'll come look at yours. You probably typed in the graph wrong, and I can come and look at that.
Okay.
Mitch.
Could you look at my Y1 later?
Yeah, I'll look at your Y1 later. Anyone at home have any questions about that last part? No. All right, guys. So what I want you working on is just finishing up